Good morning to one and all. My name is K. Madan. I am working as assistant professor in Department of IT in St. Joseph College of Engineering. Today I am going to take the class on data structure. What is data structure? What is From the name itself we can define data is nothing but the information. Structure is nothing but data are arranged in some particular order. That is a data structure. Data structure is nothing but it is a building blocks of data where the data are sequentially can be stored. That is a data structure. For example, we can able to now the data are stored in memory using that format. Now data structures are used in all the fields of big data, cloud computing, machine learning, wherever we are using in that where we access the data. So by using the schedule and using machine learning depositories where the huge number of data are stored. In this huge number of data are stored, reducing the wastage of memory, we are using this data structure to reduce the wastage of memory with the help of data structures. In this data structure, it has two types. First one should be of linear data structure and other one is a non-linear data structure. First one is a linear data structure and second one is a non-linear data structure. What is the difference between linear and non-linear data structure? Linear data structure is nothing but data are stored in a sequential order from the maybe it should be in the ascending order or it should be in the descending order, from it should be in the line by line data are stored. That is a linear data structure. Non-linear data structure is nothing but the data are stored in any random manner where the free memories are available. The data are stored in that non-linear data structures. For example, in linear data structure, we are using that of list and then stack and then queue. For non-linear data structures, the examples are tree and other one is a graph. Today we are going to I am taking to class about the linear data structures. In this linear data structure, they are using that memory allocation is on two types. First one is static and other one is dynamic. In linear data structure, they are using that static memory allocation. In non-linear, they are using that of dynamic memory allocation. Static is nothing but when the memories are allocated, it won't be changed in the runtime. But in the dynamic, we can able to change the memory in that runtime. For example, I am allocate the 100 blocks for data, but I use only 10 blocks. Remaining 90 blocks should be wasted in this static memory allocation. In dynamic memory allocation, if I allocate 100 blocks, I use 10 blocks. Remaining 90 blocks should be used for some other data. So wastages of memory can be reduced by using that of dynamic memory allocation. In that linear data structure, mostly we are using that static memory allocations. Okay. First of all, I am going to take a classes on a list in the linear data structure. I am going to take up the list. From that list, from the name itself, we can define what is list. List is nothing but data are arranged in a linear order one by one. Okay, it is a list. In this list, we are using that of abstract data type. This abstract data type is nothing but it's a collection of data and the structures. Okay, in this abstract data types, how the data are stored, what are the fields are needed for storing the data in the list. For storing the data in the list, we needed two things. One is there are two things is needed. One is a node. In this node, we need data, and other one is a next field. What is node? Node is nothing but collection of data. In the data, what is represented? One is a data and other one is next field. Node is nothing but node should be in this format. Okay, this column represent the data and this column represent the next field. This next field is used to store the address of the data for the next data. Okay, this is the node. Okay, this collection of node is nothing but list. Okay, in that list we have three types. First one is a single linked list, and second one is a double linked list, and third one is a circular linked list. Okay, these are the different types of list. First one is a single linked list, and second one is a double linked list, and third one is a circular linked list. So we have to go for what is single linked list, what is double linked list, what is circular linked list. Before going that, what is single linked list? In the single linked list, we have only one next node, we have only one pointer for representing the address of the next node. But in the double linked list, we have the two pointers, one is a forward pointer and other one is a backward pointer. In that circular links, there should not be the end node, the end node should be connected to the top first node. This is a circular linked list. Okay. So first I am going to start with that of single linked list. This is a single linked list. Okay, this is a diagram of the single linked list, how the data are stored. Okay, in this header, in this is a node. Node is collection of nodes, is a linked list. In this a single linked list, it have two types. Node will have two conditions. One is data, and other one is the address of the next node. Okay, what is the address of this here? This is 200. So it should be the address of the next node. Here 300. So 300 is the address for the next node. The last node did not have any next node other than that. The last node should be that of null. Okay. So linked list store the data in a linear order. Okay, in a arranged manner. This is a single linked list. What are the operations we are using in this single linked list is insert in the first, middle, and then last. We can able to insert any node, should be in the top, insert in the first or middle or last, where we can able to store this. And sign operation will be that of delete. We can able to delete at that of first, middle, and also at that of last. From that first node or middle node or last node, we can able to delete any node by using this single linked list, and also we can able to search the data, and also we are going to use to traverse the data. So these are the various operations where we are using that of in single linked list. Okay, in this single list, for example, I am going to insert a node between the middle of the node. How we can able to insert in this middle of the node? Okay, from this we can able to show how from the diagram stuff I show how a node should be inserted and what algorithm should be used. For example, I am going to insert a node. It should be between that of center. So it data will be of 15, its address will be that of 150. Okay, address will be the 150, the data is 15, 15. So this data should be inserted between 10 and 20 of the node. So how we are using the node? Before inserting that, we have to name a node. For example, before that node, first node will be that of P, and the new node, we have to give the name as new node for this. Okay, so from that we can able to insert a code. Okay, for example, already what is the condition? Therefore P point a next. Now I am going to insert this node in that middle. Okay, for example. So how this diagram will modify, we can able to show how the diagrams will modify. From this diagram itself, we can able to know how the new node should be inserted between middle of that singly linked list. Okay, so we already named before the new node. The new node name will be that of new node. The node it is going to start, we can name as P. Now what will happen? The new node have their address. What is the new node address? Is 150. That 150 address should be replaced in that of P, and other than that, this next node of 200, that address will be represented in that of new node. Okay, we have to modify these conditions for inserting a single linked list. Okay, from that algorithm, what happens now? What is going on? What is this node? His name is P. Though P of next, where we given this P of next, then the P of next is given to that of new node. That is a single code. Okay, for example, P or P next equal to new node. Here I assign P of next to that of new node. That is a single line. I just written here. And then what happened next? New node next should be given that of P of next. Okay, therefore new node next equal to P point A next. So we have to assign new node next is assigned to where the P next, where it should point out, that should be replaced by new node point A next equal to P point A next. Okay, so therefore now what has happened? Now the P out next is given to that of new node. This is a general syntax and general algorithm where what is happening in that of singly linked list. Okay, this is a single linked list. For example, for deleting that of node, the last node will be the nut. So for deleting, we have to use free temp. For example, I need to delete a node, so I need to name that node itself temp. For example, I need to delete this node, so I replace this node as a temp. By temp, we can able to delete this node, so this node will be replaced to that of previous node. That should be taken place in that of delete operation in that of linked list. Okay, this is a single linked list where the operation should be taken places are around here. Okay, and second one is that of doubly linked list. What is the difference between single linked list and double linked list? In single linked list, we have a single pointer to point to the next node. But in double linked list, we should have forward and reverse pointers. There should be two pointers are available. One is forward pointer and the second one is a backward pointer. From that forward pointer and backward pointers are used for that of data. From that used data, we can able to store. Okay. For doubly linked list, where how the diagram should be represented. For example, the top we have to have their header. From that header, the diagram should be replaced like this. This is a forward pointer or forward link. We can name itself forward link, and this is one is a backward link. Okay, this is forward link, this is backward link. Oh, this should be then in the center we have their datas. The next node will have we have their addresses. Okay, what type of addresses are stored? That should be represented here. Okay, for example, it should be the address will be 1000. The address of 1000 will be there. Okay, for example, this address will be that of 2000. This 2000 will be that of represented here. Okay, therefore, from the single linked list and doubly linked list, we can able to define the differences that of forward link and backward link. In the single linked list, we can't able to come reverse for accessing the data. To overcome that disadvantage, we are using that of doubly linked list. In this doubly linked list, we can able to move the data from forward or also in backward pointer also. So from we can able to access the data in the forward, how the data are accessed in the forward pointers. So we can traverse the data from the backward pointer. So this is a main advantage of that of doubly linked list while we compare to that of singly linked list. In doubly linked list also, the operations what we are used in the single linked list, that should be that of operations should be used in the doubly linked list also. In doubly linked list we are using that of insert in the first, insert in the last, insert in the middle, likewise delete in the first, delete in the last, delete in the middle. Also for searching the data, for traversing the data, for finding the data. These are the operations for sorting the data. These are the operations where we are using in the doubly linked list also. Okay, this is a doubly linked list. And third one is a circular linked list. The difference between circular linked list and single linked list is nothing but circular linked list there should not be any null value. The null value should not be present there. The last node and next link should be given to the first node. This is the main advantage of the circular linked list. Okay. Therefore, this is a circular linked list. This is a circular linked list. Okay. In that circular linked list, the last node does not have any null node. The last node data should be given to the first node. This is the main advantage. For example, there should be this should be address data should be presented, and this should have the address 100, 200, 300, 400, like this address should be represented. Here the next node address will be there 400, 300 and 200. What will happen next? The node address is 400, it should be in that of next node. Okay, therefore the last node null value should not be there in circular linked list. So the last node address should be given to the first node. This is a main advantage of the circular linked list. Okay, in circular linked list also, what are the operations we are using is that insert and then delete, the traverse and then find, and also for sorting the data. So these are the various operations where we are using in that of circular linked list also. Okay, in this what are the applications where the circular applications of the linked list are used? This is mainly they are using in radix sort. Radix sort. What is sorting? Sorting is nothing but arranging the data in any order. Okay, this is sorting. Radix is one of the method for arranging the sorting, arranging the elements. There should be n number of sorting methods are available, like merge sort, quick sort, heap sort, like that. So that is one of the radix sort for arranging the elements. And then second one where we are using that of multi list. This is a multi list. This is one of the main applications of the list where we are using in that of linked list. Okay, this is a linked list. This is a overall about of linked list. Okay, linked list is nothing but it is a collection of nodes and data. In this linked list we have three types: one is single, double and other one is circular. And what are the applications where this linked list will be used, where the data should be used, should be represented in this linked list. Okay, this is a first topic where we covered in that of linked list. And next topic, in linear data structure, the first topic of linked list that should be find out, and second one is that of linear data structure. We are going to run that of stack. What is stack? Stack is nothing but last in first out. Okay, stack is nothing but it should be that of last in first out. Okay, it should be named as LIFO, LIFO, last in first out. Okay, where this in this stack is also we are using that insertion, deletion and peek operations. Okay, for inserting the data we are named as push. For deleting the data we are named as pop. For accessing the data we are used as peek. Okay, these are the different methods are used in that of stack. Okay, For arranging the data in stack, there should be two methods are available. One is that of stack will be used using array, and other one is using linked list. First one is array and other one is of used is linked list. Okay. What is array? Array is nothing but the data are stored in that of order, in the linear order. For example, array of 10. I given the array of 10 means arrays always starts with the address of array of 0. So the data are represented by 1, 2, 3, 4, 5 up to 9. Okay. So data are stored in the linear order. This is one of the method for representing the stack data in that of using array, and other one is that of linked list. Linked list is nothing but by using that of header. From that header we represent the data in this format. If we represent the data in stack in this format, that should be represented by using that of linked list. Okay, this is the two methods are used for representing the data in that of stack. One is array and other one is that of linked list. Okay, and what are the operations are used in that of stack, we are going to see. There are two operations mainly used in stack. First one is push and second one is that of pop. The push is nothing but of insert and pop is of delete. Okay, therefore push operation is nothing but of insert and pop operation is nothing but of delete. These are the various operations taken over in stack. From the name itself we represented it is a last in first out. From that element which should be inserted in the last, that should be removed first. This is the main concept of that stack. Stack is a single open and other end will be closed. So the data should be insert or delete are taken place at the single point only. Okay. For example, first we are considering that push operation. This is a stack. The stack, the data are stored in this format only. Okay, insert and delete operations are taken place from the one end only. So data are insert and delete taken place from the top view only. Okay, from that we can able to store the data. Okay, this is a array of 0. This is first data. This is second data. This is third data. This is fourth data. This is fifth data. Likewise, the data should be stored in that order. So the element which is inserted last, that should be removed first. This is a push operation. For example, I just consider for inserting the element. Before inserting the element, I need to check whether the stack is empty or not. So I just consider, for example, I am going to insert, therefore the position I represented is that of top. I giving the name itself top for point outing the element in that of list. Okay, so I need to insert. So I just need to check if top is less than 0. Top is less than 0. What is the condition there? If top is less than 0, the data are free. Okay, therefore it should be that of data are free, so we can able to store the data. If top is greater than 0 or top is greater than max, then what happened? The data is fully loaded, so stack is fully overflow, they are taken place, so we can't able to insert the data. Okay, if so, for example, if insert if top equal to 0, then printf stack is free. So the stack is free. So from that we can insert top equal to top plus 1. Like that we can able to insert the data in the order. For example, top equal to top plus 1. For the first data we are inserted, it should be placed here. For example, 10. Then top plus 1. The next data should be represented from the top, and then top plus 3. It will grows until it will reach the maximum level. For example, I just showed given in the program itself for max equal to 10, then 10 data should be stored. Like that, it should be stored up to 10. This is a push operation where we are going to use. Okay, and second operation is that of pop. What is a pop? Pop is nothing but delete operation. In that delete operation, the data we need to check is underflow or not. If there is underflow, data are not available, the stack is empty, we can't able to delete any data. So we need to check whether the stack is underflow or not. If the stack is not underflow, we can able to delete the data. For example, here 50, 40, 30, 20, 10. So the data are available. So we can able to delete is the top equal to top minus 1. By using this code, we can able to delete one by one top. Okay, therefore free top, then we can able to delete one by one data in the top stack using that of pop operations. From that we can able to delete top equal to top plus 1. For inserting for top equal to top minus 1, we can able to delete that data where we can store that of top equal to top minus 1. And next one is that of peak operation. This peak operation is nothing but we can able to search the data and we can able to traverse the data in the stack. These are these peak operation is used by using this stack operations. Okay, this is a stack operation. The next one is the application of stack, where this stack should be mainly used. First one, this should be used for evaluating the arithmetic expression. Evaluating the arithmetic expression. Arithmetic expression is nothing but what, for example, we have to give the data. For the data, we for any constant we have give the any numbers. From that operations, it should be, for example, a plus b star c. I have to store this data. For example, I given a equal to some number, b equal to some number, and c equal to some number. So by using these operations, it can able to analyze and find out what is the final output for this operation. For example, the a and b and c, these are the operands, plus and star, these are the operators. Okay, so based on that values, it will find out what is the final output will become. This is the evaluating the arithmetic expression should be there. And second one is that of postfix to infix conversion. This is the main concept where the postfix to infix conversion. What is the postfix to infix? There should be three types. One is prefix, and for second one is of postfix, and third one is that of infix. Okay, in this infix will be that of a plus b. If this is of infix, for example, if the operator is present between the operand, then it should be that of infix. Prefix is nothing but the operator is present before the operands, there should be that of prefix. For postfix, the operator is next to that of operands, that should be that of postfix. This is a conversion of postfix to infix conversion. This is the main applications of the stack where we are using that. Okay, and third one is that of Tower of Hanoi. This Tower of Hanoi is nothing but how the elements should be stored in the order. For example, I am able to allocate the data in that of based on the weight. For example, 100 kg is that of below. From that 100 kg, I just to store any 50 kg I need to insert next node that should be placed above 100 kg. I need to insert 150 kg, it should be stored less below 100 kg. Likewise, it should be ordered. That should be using by using that of Tower of Hanoi. And the other one is that of next application is that of function call. Function call, by reducing the number of codes in that of programming lines, we are using that of function calls. By using that any functions, we can able to reduce the number of lines of codes and that of reduce the wastage of memories. There we are using that of function calls. And next we are using that of recursive function, where we are using that of recursive function. Recursive function is nothing but repetitions of data, where we are using that of looping operations repeatedly. There we can use that of recursive functions. These are the various applications of stack, and this is a stack. And second method we have shown, stack is nothing but this is a LIFO. The operations we are used is push and pop, where the applications are using that of stack. And next we are going to see about that of third operation is that of queue. What is the difference between stack and queue? Stack is last in first out. The element should be inserted in the last, or it should be deleted in the first. That should be that of stack. In the queue, nothing, that is should be first in first out. That should be FIFO. First in first out. This is the FIFO. The element that should be inserted first, that should be deleted first. Okay. For application of stack, this is nothing but that of we are for example wearing the bangles by the ladies. That should be a best example for application of stack. For that of queue, the best example is a ticket, taking the ticket in the cinema theater in the queue. That should be the best example for that of queue. Okay. In this queue, the operation is, it is also data to be represented using array, and other method is using linked list. These two methods are used for representing the queue methods. One is array and other one is linked list. Okay. In this queue, it should be two types. One is doubly ended queue, and other one is that of circular ended queue. These are the two types where we are using in that of queue. One is doubly ended queue and other one is a circular ended queue. The operations in the stack we have shown is, one is push and other one is pop. Push is used for insert and pop is used for delete. Likewise, here in queue we are using the operation is enqueue. This is used for insert, and second one is of dequeue. This is used for delete. First one is of enqueue and second one is that of dequeue. This is a queue. For example, this is a queue order. The element that should be inserted first, that should be deleted first. Okay. The elements are inserted in that of rear end. There should be two ends. Insert end will be that of rear end, and delete end should be that of front end. Okay. Where we can able to insert and delete. In that rear end we can able to insert the element. In the front end we are able to delete the element, where we can insert in the rear end and delete in the front end. So this like then only we know the name that first in first out. The element that should be inserted first, that should be deleted first. This is the main advantage of front queue. For inserting operation is nothing but enqueue. In this we are using the code rear equal to rear plus 1. This is the main code where you are using for inserting the data. For dequeue should be taken place at the front end. So front equal to front plus 1. This is the main code should be used for deleting the data. Before inserting the data, we need to check whether this overflow or underflow is taken place or not. There should be any overflow is there, we can't able to insert any data. In delete operation, if any underflow is there, we can't able to delete any data. So that condition should be checked before we are using that enqueue and dequeue operations. This is a queue operations. In this, a doubly ended queue is nothing but where we can able to in doubly ended queue is nothing but where we can able to insert and delete at the both ends. Insert and delete operation should be taken place at the both the ends, then we are called as a doubly ended queue. that of circular ended queue. Next one will be that of circular ended queue. In the circular ended queue, it should be in that of circular manner, where we can able to store the data like array of data will be that of array of 0, array of 1, array of 2, array of 3, array of 4. Like this we can able to share, where we can insert it should be that of rear and delete and will be that of front. And this is a circular ended queue. And next, the applications where we are using this applications of queue is, first one is that of in queue sections, and second one is of scheduling, where the operations which will become first in first out, like round robin scheduling, first come first serve, priority scheduling. Likewise, the different scheduling applications we can use that of queue operations. These are these various applications where you are using in the queue. This queue is first in first out. This has two types, one is doubly ended queue and circular ended queue. The operations are enqueue and dequeue. In enqueue, will be insert is taken place, in dequeue delete is taken place. For inserting we are using rear equal to rear plus 1, for deleting we are using front equal to front plus 1. This is the applications of queue. This is for scheduling of different algorithms. Thank you. Thank you, sir.